This is lesson 214. Make sure you have your name on it, today's date, and also which period you're in. So lesson 2.1.4, what information determines a line? Lately we've been working a lot with y equals mx plus b. But we're also going to be learning a lot more about slope today, a lot more practice. That's going to really help you for this upcoming quiz or test. So it says, let's introduce the lesson. I'd like you to work on some problems with your group. But it says, in previous lessons, you found the slope and y-intercept of linear functions. Okay. Every time you think of linear functions, you want to think it's just a line. It's the word line, linear. You connected slope, which is growth, and y-intercept, which is starting value, to the representations in patterns, tables, equations, and graphs. This is the multiple representations that we're trying to get really good at. Do amazing today. Let's see. Today you will complete your focus on determining slope. So focus on slope. And learn how to use slope and the y-intercept to write the equation of pretty much any line. During this lesson, please keep the following questions in mind. How do we determine growth? How do we determine the starting value? Is there enough information to graph a line? And how can we calculate slope without even graphing it? Wow, that's a deep question right there, but we're going to be working on these ones during this lesson. So let's start off with problem 2-35. Take some time to read this with your group and then answer the questions. Then we'll check. Okay, so equations for linear patterns can all be written in the form y equals mx plus b. Let's check our work. It says x and y represents variables. When you wrote equations related to the figure number to the number of tiles, what did x represent? What did y represent? X, that was your figure number, your input, your figure number. Y was the number of, that's right, for tiles, it was going to be the number of tiles. That was your output. Okay, it says m and b are parameters. They do not change within a given linear situation. M is also called a coefficient since it multiplies a variable x. And b is a constant term since it does not multiply a variable. Okay, essentially m is in front of x. So you're multiplying by m. And then b is just a constant term. It does not change. It's just, if it's plus 3, it's always plus 3. Next question. What do m and b represent in a linear situation like the tile patterns? M in tile patterns represents growth. Your slope, of course. M is slope, which is growth. And b, check your work on this one. B was the... For tile patterns, was it starting value? Was it the y-intercept? Yes, it was actually called figure 0, which a lot of people like to write down as F0 for short, or fig 0. Next question, let's check our work for this one. What effect does M have on the graph of a line? Let's answer that first question here. What effect does m have on a graph of a line? So m is the slope, which changes the growth, which changes if you draw some different lines. It changes the y-intercept. So it affects the position of the line. Remember, B can change wherever it is on the y-intercept. B can make the line go up here, B can make the line go up here or down here. B just changes the position of that graph. All right, go ahead and flip your paper. Let's go ahead and check our work for the next one. This is the line factory. Line factory. So, line factory, go ahead and take some time. I want you to take a few minutes to work on this one with your group. Problem 2-36. And go ahead and help each other out. Choose someone to read the problem and then try to answer the questions in the line factory. It says, you are an engineer at the city's premier line factory. Your job is to process orders for lines. Can you create some lines from these details that are given to you here? Take some time, answer it, and be ready to share your answers. By the way, it does use the resource page, so you do want to graph these lines based on the information given to you. All right, let's bring it back. So here we go. Let's check our work for these problems. It says line A, again, it says if you do not have enough information to draw one specific line, draw at least 2 lines that would fulfill the order. So for line A, it says it goes to the point 2, 5. So let's check that one. 2, 5. That's the only information we have for line A. So how many lines go through 2, 5? Right? You can have a positive line, you can have a negative line, or a negative slope. You can even have a slope that goes through vertically. What kind of slope is that again? If it's a vertical line? Right? It's called undefined. Remember, these questions are just something that we want to practice and practice. So this one's positive, this one's negative, this one's undefined, and there's no equation for that first one. Okay, let's check line B. Line B has a slope of -3 and goes through the origin. Okay, where's the origin? The origin is, that's right, 0, 0. So let's see. For letter B, do you draw a line that goes through 0, 0 with a slope of -3? So we have y equals -3x plus 0. Well, we don't need to write plus 0, so that part is not necessary. This is the equation of that line. Now, a slope of -3 means it goes down 3 every 1. Down 3 every 1. So this line will look something like this. Okay, let's go ahead and check our line C. Line C goes through the points -3, -2, and 3, 10. So let's make sure that we have those two coordinates graphed. Line C. -3, -2. Left 3, down 2. And the second coordinate was 3, 10. So 3, 10 is 3 for x, 10 for y. How many lines go through those 2 dots? Exactly, there's only one possible line that goes through that dot, so those 2 dots. So according to what I'm seeing here, what's the slope? Because I need to write the equation of these ones, right? The slope appears to be 1, 2, 3, 4, 5, 6, 7 over, it's kind of hard to see this one a little bit, but it looks like it's going 7 over 3. 7 over 3. Yeah, 7 over 3 is correct. So y equals 7 over 3 x plus, and what's the y-intercept? Plus 3. A little challenging for that equation, but again, this graph does match that equation. Okay, let's go over line C. or that was line C. Let's go over line D. Line D has the following table: 2, 1, 3, 3.5. Let's graph those points. Make sure we have this down. 2, 1, 3, 3.5. Where's that at? About there? 4, 6. 4, 6. Right there. And 5, 8.5. Something like that. The only line that goes through those ones are going to be this right there. And we could come up with the equation for that, but I'm seeing the slope is pretty complicated to see that one, okay? So we'll leave that equation blank for right now. Okay, next one is line E. Line E has a slope of 4. Let's check our work for that one. How many lines have a slope of 4? Could put a dot anywhere we want. Do a slope of 4. 4 over 1. 4 over 1. This one has a slope of 4. What about this line? Because this is not the only line with a slope of 4. Put another dot and create a slope of 4. 4 over 1. 4 over 1. That's another line that has a slope of 4. So these ones wouldn't have the same equation. They'd have the same slope, but not the same equation. Okay, let's go ahead and check letter F. Line F goes through 8, -1. Let's find 8, -1. And it says it has a slope of -3 over 4. So a slope of -3 over 4 goes down 3 and over 4. So we know the equation would be -3 over 4x plus, and I did not draw this perfectly. I'm using a marker, so it's hard to tell where the y-intercept is, but I'd probably say close to +3. I'll put a question mark because we're not entirely sure, and that's okay. Finally, we have customer G. Customer G had the following table here. So let's graph those points. 0, 1, 1, 2. Ooh, this one's weird. 2, 4. 3, 8. And 4, 16. That one goes off the graph. Did you notice this one actually, if you graph these coordinates, is this actually a straight line? You can say, sorry, this one's not even possible. This is not going to be growing by the same number each time. You see, it's actually, if you look at the table here, it's growing by 1, then it's growing by 2, then it's growing by 4, and then it's growing by 8. That is not linear. What's another way to say not linear, by the way? We could also say, yes, non-linear. So those would be our answers there. If you got several of these, nicely done. Some of these are more difficult, as you can see, but that is the correct answers. The correct answers we're looking for, or as close to correct as we possibly could. So that was pretty good practice with slope. Pretty difficult and challenging, but also pretty good. Go ahead and make sure to turn to the last page of lesson 2.1.4. All right, with your team, please try out problem 2-37, and if you're done quickly, answer the question 238. What is the steepest slope? Take some time, help each other out. All right, let's go ahead and check our work for problem 2-37. It says calculating slope without graphing. Wow. While determining the slope of a line that goes through the points 6, 5 and 3, 7, two different coordinates, Gloria figured out that change in y is -2 and change in x is 3 without graphing. Did anybody figure out how you can decide what Gloria, how did Gloria figure that out? Because this is very powerful to see the change in y and change in x, because that's all you need for slope. So in here you wanted to explain how Gloria figured that out. So what did you figure out? So now your chance to share. We'll pause the video here. All right, so someone hopefully shared this one right here. 5 to 7, which is the y's, would be, what's 5 minus 7? Negative 2. That's our change in y, our y values. What about the change in x? From 6 to 3, 6 minus 3 is 3. That's our change in x. Yeah, so that is exactly how you figured it out. What was the slope of this line? Again, what is slope? M is change in y over change in x, which if you want to, you can add some color like I did. Change in y was negative 2, and change in x was 3. And if you simply write that as a fraction, that's your slope. You got it. So use the same method. Let's check our work with this one. Use Gloria's method to figure out the slope of this line. So 15 minus 11 is 4. And 4 minus 2, the x's, is 2. Now, if I label this change in y over change in x, we get 4 over 2. What's 4 divided by 2? Yes, 4 divided by 2 is 2. Let's do the next one. Use Gloria's methods to calculate the slope of the line that goes through these 2 points. So the same thing. Change in y. How does y change? 86 minus 3. Sorry, 86 minus 83 is 3. And what's 28 minus 34? This one's weird. I think this one's a negative number. 28 minus 34. Let me ask Siri for this one. What's 28 minus 34?
That would be negative 6.
Negative 6. What is 3 divided by negative 6?
That would be negative 0.5.
So this one would be negative 1/2. Just cutting these numbers by 3, dividing by 3, divided by 3, you can simplify the fraction and get negative 1/2. Remember we talked about the negative number? Why would you put negative on the bottom when you could put the negative on the top or the left side? So that's true. Another student found the slope for this previous problem. You notice it's the same problem here, and got the answer of 2. What errors did that student make? What do you all think? I'm going to pause the video here. What do you think is the answer for this question? How could you make a mistake and get the answer of 2? So it's an error or errors. The first error that could possibly be made is instead of doing change in y, you could do change in x, doing the wrong one first. So if we did 34 minus 28, perhaps in the wrong order, 34 minus 28, we would get 6. And if we did 86 minus 83 in the wrong order, what will we get? 3. What's 6 divided by 3? 2. So we learned that we know this is not correct. This is the wrong answer. We need to do change in y over change in x. So we can make a little note here. Always do change in y over change in x, not change in x over change in y. All right, final question, problem 2-38. What is the steepest line possible Remember, lines can get steeper and steeper and steeper and steeper and steeper. What is that line if it's the most steep ever? Yes, that line is a line that has a slope that is undefined. All right, that wraps up this lesson. Go ahead and move on to any review or practice. And if you have any questions, please reach out.